Welcome to MyProjectBazaar.com. Our project title is On-Demand Discovery of Software Service Dependencies in MANETs. Abstract. It is important to determine the dependencies between the nodes in mobile ad hoc network. Sometimes fault localization may occur. Some dependency discovery methods are used earlier for fixed network. Dynamic dependency discovery method is proposed for achieving the better fault-tolerant mechanism, which gives better result than existing method. The performance of our method in terms of the accuracy of the discovered dependencies and draw insights on the selection of critical parameters under various operational conditions. Let us see the flow of our project. First, network is forming, then we have to estimate the neighbors. Then depending upon the neighbor, the service discovery is done. The monitoring nodes are formed and transform the information to via that nodes. That is, if any node have service dependence, that is the node act as, if any node will act as a source node as well as relay node. So this monitoring algorithm is used for identifying the service dependency. If it is validated, we have to identify the network dependency also, and data transmission is done. The monitoring node do these all process. So all process must be within this monitoring algorithm, and for that evaluation we have to estimate four parameters. First one is energy, second one is delay, third one is throughput, and fourth one is packet delivery ratio. Let us see the output of our project. First, open this terminal window. Before running our project, first set the path for our NS all-in-one 2.34. Our package is NS all-in-one 2.34, so set path for that. So type gedit space / .bashrc. For that, one notepad window is opening. In that we have to change this, as I already changed it. So in existing system it like 2.28, so we have to change it in 2.34, and NAM window as 1.14. Then close it and type cd space ns all-in-one 2.34, then cd space ns 2.34, then make for configuring the file. So our project seems errorless program. So again open the terminal window and type cd space code, that is our code folder. Then type ns space main.tcl for running our tcl file. TCL is nothing but tool command language. We have to implement front end, that is for network formation we use TCL language, and for protocol design we use C++. So this is our network animator window. When we start on this play forward button, it works. This is for simulation speed. We have to increase or decrease it. Now four groups of cluster is forming, because we have to done our data transmission between the social networks. So many networks are there, so we have to clustered four regions. So what is going on there is annotated in this place. Now four cluster region is forming. Then we have to identify that monitoring node. If there is service dependencies between we have to identify that service dependency as well as network dependency. If a node is between the in one cluster means it sends via that information. That is, if the node is in another cluster means it sends the information to that monitoring node, and monitoring node sends the data forward the data packet to that particular node, that is destination. So monitoring node have all rights to identify the dependency because a node which is act as source as well as relay as well as destination. So now 23 is act as a source and 33 is destination. So the monitoring node have only rights to identify if any service dependency between these 23 and 33. If any dependencies between these 23 is and 33, it wait and transmit afterwards it finish that dependency informations. For running our graph, type GNU plot space thr dot plot for throughput. So this is our throughput comparison. Our proposed system is depicted as this green color and existing is depicted as this red color. So we have to compare mean node speed versus average throughput per flow. So our proposed system achieves greater throughput than the existing system.